Good day. Welcome to today's class. And today's class we'll be looking at Introduction to Organic Chemistry. Introduction to Organic Chemistry. My name is Olalure Rabiu, and the topic for today is majorly for students who are preparing for WAEC exams, NECO exam, JAMB, GCE exam, and also post-UTME exams. They serve as the basis for those who are writing these exams. Basic topics for those who are writing this exam. So in this lecture, we'll be considering the following topics. Number one, we look at the introduction. We give some examples of substances around us that are organic. Then we also look at what is organic chemistry. How is organic chemistry defined? What is it all about? Then we look at homologous series. We define what the homologous series is, the characteristics of the homologous series, and we also look at the functional group. What do you mean by functional group? How do you determine the functional group of a compound or of an organic compound? How do you know the family of the homologous series the compound belongs from the functional group? Then we look at the hierarchy nomenclature. How do we name organic compounds? What are the rules guiding naming organic compounds? Then we also look at isomerism. What is isomerism? We look at the different type of isomers that we have. Now we'll go to the introduction part. Introduction. Have you ever wondered what makes your perfume smile? Or what makes sugar sweet? Or your air freshener, what gives them the sweet smell that we have? May I tell you? Let's see. Do you also know that the same carbon that is found in diamond, we know diamond should be one of the allotropes of carbon. So the same carbon that is found in diamond is the same carbon that is found in the food. And the food that you eat, and the fuel you burn in your car, do you know it's the same carbon that is present in them? What about the ink in your pen, the soap you use, even the clothes? I hope you know they are all products of organic chemistry. Do you also know that the DNA that makes up our life is also an organic compound? What about talk about perfumes, plastics that we use at home, plastic materials for different products at home? Talk about your bucket. Do you know they are products of organic chemistry? What about the polymers, some of the polymers that we use for making our clothes materials? The polymers that we use for making cloth material, the polymers, polyesters, do you know the organic compound? Some medicine, the drugs we take, they are also organic compounds. Also the food, we have said that carbohydrates, fats, protein, they are all organic compounds. They are all product of organic chemistry. So we welcome you to this lecture as we explore what the secret, one of the secrets of the recipe of the universe, the science that is behind everything that you see, you smell, or you touch, and that is organic chemistry. You are welcome once again. So let's go into the topic. What is organic chemistry? Organic. When you say something is organic, what does it mean? Organic chemistry. No, when we mention the word chemistry, most at times we usually think most about chemical reactions. Chemical reactions, that is what a layman see chemistry has. When we talk about chemistry, talking about reactions, changes that happens to matter, the properties. Now we are looking at an aspect of organic chemistry. We have different branches of organic chemistry, which hopefully we have done some parts. The physical chemistry, we have the inorganic chemistry, we have the environmental chemistry, we have the biochemistry. But here we are looking at the organic chemistry. What does the word organic? What does it mean? Uh, Organic chemistry, formerly, organic chemistry was defined to be the chemistry of naturally occurring substance, and that is why the word organic is there. Compound, naturally occurring substances, that is, substances that we believe to only come from plant and animal origin. There are no other sources where these substances can be obtained except from plants or from animal, from living things. That's why they gave the definition naturally occurring substances. That these substances, there is no way they can be produced in the lab, that they can only be obtained either from plants or from animal. Example of such is urea. But the definition was later disproved. How? What happened? There was this scientist called Frederick Euler. He was able to produce an organic compound that we call urea. The organic compound urea from ammonium cyanide. Other other chemists came up with different ways of producing some of these organic compounds, and that was why the definition was disproved. Now, how do we define organic chemistry? Since the first definition was disproved, how do we now define organic chemistry? Now we define organic chemistry as the chemistry of carbon compounds. Carbon compounds. Remember in the introductory part, I made mention of carbon. As the same carbon that is in diamond, it's also the same carbon that is in the food that you eat and the fuel that you put in your car, the fuel that burns in your car. So carbon is here is seen as the center of all organic compounds. So what that means is any organic compound that you have, when you have an organic compound, then it contains carbon. But that does not mean that all compounds that contains carbon is organic. So we have some exceptions. So some exemptions of carbon compounds are not organic. And what are they? Your carbides. Calcium carbide, any carbides are not organic compounds. Your carbonate, talk about sodium carbonate, potassium carbonate, the hydrogen carbonate compounds, they are not organic compounds. The carbon monoxides and the carbon dioxides, which are the two oxides of carbon, they are non-organic compounds. So the oxides of carbons, the carbides, the carbonates, they are not organic compounds. So any compound that contains carbon, with the exceptions of the following of the compounds listed, they are organic compounds. So chemistry, organic compounds, organic chemistry deals with the chemistry of carbon compounds. We study carbon alongside with some elements. Now the question is why? Why is carbon the central of organic compounds? Why is carbon? So I listed here 4 reasons why carbon is seen as the central of all organic compounds. Number 1 is because of its tetravalent nature. Carbon has a valency of 4. You may ask, is the only carbon that has a valency of 4? No. We have some other elements which are in the same group as carbon, and they also have a valency of 4. And they also have a valency of 4.